So we are recording this review for chapter 8. In a study to determine strength of a basic back kick and a reverse high punch in karate, data were collected from 10 black belt subjects. So it is believed that there is no significant difference in the two as far as strength when executed by an expert. Use the data given below and a hypothesis testing technique to determine if this belief seems to be true. Okay, guys, so we said we're going to do the differences. This is L1, this is L2, and we did L1 minus L2. These samples are dependent, guys. So your hypothesis test is going to be one of those three. Mean of the difference against 0. And what would be the signs? He says, it is believed that there is no difference. So what would be your null and the alternative hypothesis? If I put the three of them, guys, here, tell me which one would you select. So I'm going to write the three scenarios.
Wouldn't it be equal or not equal?
Yep, that is correct. I'm just going to remind you of the scenarios. And that's the third, and that's our scenario. No difference means equal to 0, guys. Difference, no difference. That is ours, and it's going to be equal to 0. That's the claim. If I tell you guys it doesn't make difference whether you use method 1 and method 2 to study for the test. So it means if you study for the test using method 1, let's say you get 78%. If you study using method 2, you're going to get 78. So 78 minus 78 is 0. So that means there is no difference. And that's what the question is about. It's going to be a t-test, guys. And we already have
the calculator. We can't see what you're writing.
Oh, you didn't see anything that I did on the calculator?
No. Like what you're actually physically writing, because a calculator.
Oh, yeah. Okay, let's right here. Can you see my writing now, guys?
Yes, thank you.
Yeah. And now, guys, we're going to run a t-test. So we're going to go to stat, tests, t-test. Again, for students who are wondering, when do we use two-sample t-test? We use two-sample t-test when the samples are independent. When they're given like this, that means the samples are dependent now. It's the same subject using a punch and using a kick. So t-test, data, 0 here in section 8.3, it's always against 0. But remember, my difference is not in L1 now, it's in L3. So I have to use second and number 3 to go to L3. Frequency, don't change it. And we need not equal to for the alternative sign. And here you go, guys. Let's do a draw if you like to see the p-value in action. You're going to see two tails, guys, here because it's a two-tailed test. So it's a huge p-value. It looks like a big p-value. And okay, my test statistic is 1.3828. Is it 30 or 38? 30. 303, and my p-value is 0.225. I'm gonna remove the calculator. We don't need that, which is bigger than alpha, of course. He didn't give you alpha, it doesn't matter. We use 0.05, but it's a huge p-value. So fail to reject HO. There is not enough evidence at the 0.05 level of significance To, what's the magic word, guys? The claim is in HO.
Reject.
To reject the claim that there is no significant differences in the two as far as strength. That there is no significant difference. I'm just copy and paste in the two which is the punch and the kick as far as strength. We could not reject HO. So does this mean, guys, that the belief seems to be true? Yes or no? The belief is that there is no difference. So what do you think? A yes or a no for the last question? We did not reject HO. So that means HO probably true. And then, yes, the belief probably seems to be true. We cannot confirm that, but we cannot reject it. All right, so that's number one. Number two. Let's see what this one is. So that's a t-test right here. Let's see what this one is. Look at the statement at the very end, guys. It says, and that population variances are not equal. That's a hint for you that this is a two-sample t-test, because pooled here is going to be a no. Two-sample t-test. I'm going to set it up on a separate page. And that's number two. So we did number one of the review. Newton County and Fulton County use two different procedures for selecting jurors. So we have two counties, Newton and Fulton. So we need N1, we need X1 bar, we need S1, and we need N2, X2 bar, and S2. It's going to give me all those information, guys. And we need alpha. So let's see what he says. The mean waiting time for the 23 randomly selected subjects from Newton County. So N1 is 23. The next one is the mean waiting time, which is X1 bar, is 183 minutes. With a standard deviation of 21, that's 21 minutes. He didn't say population standard deviation. That's why I didn't call it sigma. I call it S. Unless if he says a population, then it's always a t-test. The mean waiting time for the 17 randomly selected subjects from Fulton, at 17, it's 202.1 minutes. And with a standard deviation of 29.2. Test the claim that the mean wait time of prospective jurors is not the same for both counties. Use a 5% level of significance. Assume that the population are normally distributed and that the population variances are not equal. Okay. That should be easy, guys, for you to determine the null and the alternative. He says, that's the claim that they are different. So mu1 equals mu2 and mu1 not equal to mu2. These samples are independent. There's one hint for you to know that the samples are independent. Look, 23 from the first one and 17 from the second. Two different groups of jurors, one in Newton County and now one in Fulton. It's not like we're taking one patient, we're giving them a medication before and after to say that they are dependent samples. So these are independent samples. And alpha is 0.05. And I'm done with the wording here. All I need just to run the test. So it's going to be a 2-sample t-test. Let's do that. Clear. Okay, you're ready, guys. You can do it with me. Stat tests. 2-sample t-test. Summary. X1 bar 183. S1 is 21. N1 is 23. X2 bar 202.1. S2 is 29.2. N2 is 17. And different from, that's what we need. Pooled is no, guys. So select no. And hit. Let's do a draw. Takes time, but it's going to be a 2-tailed test. So if there is a p-value, it's going to show on both sides. Watch. You're going to see the same shading on the right-hand side. Watch, guys. That's a p-value, twice the amount. It's small. So T is negative 2.294. And the p-value, I read, guys, 0.0296, which is less than alpha. And we reject HO because it is less than alpha. And we conclude there is enough evidence at the 0.05 level of significance. Oh, the claim is right here, sorry. To what, guys?
To support.
To support the claim. There is enough evidence to support the claim that there is a significant difference in the wait time. Yeah. Done. That's number 2. Let's go to number 3. All right. Number 3. Before beginning and upon completion of a 4-week exercise program, the weights of the students were taken. So it's the same students before and after, before the beginning and after completion of the, so here I could have put student 1, 2, 3, 4, 5, 6, 7, 8, 9 students. The weight of the students were taken. Use the data given below to test the claim that there is no difference in the pre-weight and the post-weight. Use a 5% level of significance. Okay, guys. So these samples are dependent. So we have to do the difference here. You can do it on your calculator. We can do it by hand. Let's do it by hand. That should be faster here. So 118 minus 123 will be negative 5. 126 minus 131, it's negative 5. 134 minus 132, it's a 2. 162 minus 159 is a 3. 145 minus 138 is a 7. 188 minus 182 is a 6. That's a 3. 125, now negative 3, and that's a 0. Okay, guys, we have 3 scenarios. Tell me which one is going to be. Test the claim that there is no difference. So would it be 1, 2, or 3?
3.
3. And no difference means equal to 0. Difference means not equal to 0. So it's going to be 3, and the claim is going to be in HO. So this is going to go to L1. Put the difference in L1, run t-test. And that's HO, HA, guys, MUD equal to 0, not equal to 0, and that's the claim. Okay, let's run the t-test together. Stat, edit, I'm gonna clear. And guys, we're gonna just enter the differences. -5, -5. The negative sign is right under the number 3, so don't use this operation, this negative here, guys, as a negative sign. It's not right here. That's not correct. This is the correct one right here. That's a negative sign. Two, 3, 7, 6, 3, -3, 0. I mean, it was easy to do the difference by hand, whereas with the one that I showed you, it has decimals, so it's good to use technology. But this one, making the subtraction by hand is not a big deal. And now you go to stat, tests, t-test. Again, data, guys, you have to select data. You do it always against 0. That's the screen. Frequency is L1. Don't change the frequency, number 1, leave it. And we need to do different from right here. I'll do a calculate. There you go. So T is 0.598. P-value is 0.5661, which is bigger than alpha. We fail to reject HO. And we start with there is not enough evidence at the 5% level of significance to reject the claim. We are saying that we cannot reject the claim, so probably the claim is true. When I don't reject your argument, guys, it doesn't mean that your argument is correct, but it's probably correct. I just don't have enough evidence to reject your argument. That's what it means here. And that's number 3. Any questions about number 3? Okay, number 4. Let's do number 4. 2 different cereal companies make a Raisin brand cereal. 12 different 18-ounce boxes are randomly selected for each brand. So these are independent samples, guys. We're taking 2 brands of cereals, so they're totally different. So it's not like a before and after, just like number 3. For each brand, and the contents weight. Brand A has a mean of 18.15 and a standard deviation of 0.20 ounces. Brand B has a mean of 17.95 ounces and a standard deviation of 0.5. Is there a significant difference in the weights of the 2 brands? Assume that the population variances are equal, so that means pooled is yes, and that population are normally distributed. So that should be a 2-sample t-test, guys. That should be obvious. So let me just put the data in there, and I'll show you the screen. So we have brand A and brand B, and we have how many of each? 12. So N1, guys, is 12 for the first one, and N2 is 12 as well. For X1 bar, we had, what did he say, the mean? 18.15 ounces, and the standard deviation, guys, was 0.2 ounces. And for brand B, it has 17.95 and a standard deviation of 0.25. And alpha is 0.05. And he's asking is there a significant difference? So guys, here are the 3 choices for this. I'm gonna write them down. This is 1. This is section 8.2 we're doing. This is 2. That's what makes this chapter easy, because you only have 3 choices always. You just pick one of them. What is it going to be? He says, is there a significant difference in the weights between the 2 cereals? So would it be 1, 2, or 3, guys?
3.
3. I agree. So we're going to state them. You could label it A and B if you want, guys, if that will, sometimes he labeled them A and B because he uses A and B, and this is the claim. 2 sample t-test. And he says, assume population variances are equal. Let me just state what that means. That's a hint for you guys. It's a 2 sample t-test. Are equal means pooled is yes. So let's run the test. Not data, it's a summary. X1 bar is 18.15. S1 is 0.2. N1 is 12. X2 bar is 17.95. S2 is 0.25. N2 is again 12. Not equal, and pooled is yes, guys, as we agreed. And let's hit calculate. So T is 2.164 and the p-value is 0.0416. So guys, let's write them down. T is 2.164. P-value is 0.0416 and less than alpha. So reject HO. If you reject HO, guys, and your claim is in HA, you support the claim. As simple as that. So there is enough evidence at the 0.05 level of significance to support the claim. That's how we. A study of reaction time was conducted with 11 randomly selected volunteers. Their reaction time in milliseconds before and after the consumption of an energy drink was measured. Guys, before and after, that's an indicator that the samples are dependent, so you must do the subtraction. Just keep that in mind. Use hypothesis testing technique to test the claim that reaction time is different after consumption of this beverage. So different. What is it gonna be, guys? HO and HA. It's gonna be different from what? The 0 equals 0, and that's the claim. But you need to do the difference here, D. If you wanna do it on the calculator, you can do that. If you just wanna do the subtraction right here manually, you can do this as well. So let's do the subtraction, just quickly using the calculator here. So 469 minus 597. Okay, I got negative 128. 563 minus 614. I got negative 51. 693 minus 650, I got 43. 737 minus 733, I got 4. 706 minus 721, negative 15. 595, that's 18. 634 minus 618, that's 16. 511 minus 561 is negative 50. That's 8. That's a 7. And 496, guys, minus 463 will be a 33. So you're going to put this data in L1 and run the test. Okay, so let's put it in L1. Clear, stat, edit. I could put it in L2 if you don't want to erase L1. So just hit clear and enter. That will erase L1. So negative 128, guys. Negative 51. 43. So I have positive and negative. Let's see what's going to turn out. Negative 15. 18. 16. Negative 50. 8. 7. 33. And you go to stat, edit, tests, t-test. Data, again, 0 always. When you do section 8.3, your data is in L1 and your alternative is different from 0. And hit calculate, guys. And that's it. T is negative 0.706. And the p-value, oh, it's a huge 4966. So let me write them down. I strongly recommend, guys, that you go back and redo those exercises, and now you have the answers, which is bigger than alpha. Fail to reject HO. There is not, I'll capitalize not, from failed, not enough evidence at the 0.05 level of significance to the claim is in HA to support the claim. We're saying we cannot support the claim, so maybe the claim is wrong. We're saying there is not enough evidence to support the claim. Okay. So an instructor wants to compare the number of hours a student studies for a calculus exam to the number of hours a student study for a statistics exam. The instructor takes random samples of his calculus students and statistics students, determine at the 5% level of significance whether the two courses have different mean study times for an exam. Assume population variances are equal. So that should be easy, guys, to figure out that HO, HA should be mu1 equals mu2, and mu1 not equal to mu2. Here, mu1 refers to calculus, and mu2 refers to statistics. And the claim, whether...
I have a question. Are you writing the information down on number 7?
Well,
Because isn't this number 6?
You're absolutely correct.
Okay.
Thanks for noticing. We'll fix it right here. I was wondering myself. Okay, so that's a claim. And we run a 2-sample t-test, guys. And since he says population variances are equal, pooled is yes. And that's it. So let's run the test. Stat, tests, 2-sample t-test. Data, this time it's data. We don't have a summary. My data is in L1 and L2, which is good. 1 and 1 and different from Pooled is yes, that's what I need. And let's do a draw if you like. And watch the results shown on the screen. Oh, it's a huge p-value here. So we're going to fail to reject HO. So T is 1.548 and p-value is 0.1373. What was it? 1.548. P-value, guys, is 0. So here pooled is yes. Just make sure to change this properly, otherwise you will get wrong answers. Fail to reject HO. And there is not enough evidence at the 0.05 level of significance to support the claim. To support the claim whether the two courses have different mean study times for an exam. So it seems like probably they don't have a different mean study times. They're both very much the same. Next exercise, number 7. To compare customer satisfaction levels of two competing cable television companies. 74 customers of company 1 and 35 customers of company 2 were randomly selected and were asked to rate their cable companies on a 5-point scale, with 1 being least satisfied and 5 being most satisfied. The survey results are summarized in the following table, which is, I think it's going to show probably next on the next page. Test at the 1% level of significance whether the data provides sufficient evidence to conclude that company 1 has a higher mean satisfaction rate than does company 2. So would you guys agree with me if I switch this to greater than, because he says higher satisfaction rate, and that will be less than or equal to. That should be the null and the alternative hypothesis. And let's see what the data has here. Just one sec, let me just get that. Okay, guys, so we have HO, mu1 is less than or equal to mu2, and we have HA, mu1 is greater than mu2, and that's the claim. Okay, look at the table, guys. What kind of test is it gonna be?
2-sample z-test.
Z-test, because he gives you sigma 1 and sigma 2. He didn't give you S1 and S2, and he didn't say anything about population variance is equal or not equal to use a 2-sample t-test. So it is a 2-sample z-test. Okay, let's run the test together. Stat. It's number 3. It's summary. Okay, sigma 1, first thing, 0.5. Sigma 2 is 0.52. X1 bar, 3.51. N1, 74. X2 bar, 3.26. N2 is 35. And we need to check that the first cable company has a higher rating than the second, so greater than. And here we go. Z is 2.37, and the p-value is very small, as you can see, guys. It's 0.0088. So Z is 2.37. P-value is 0.0088, which is, of course, less than alpha. That's a very small number. We reject HO. there is enough evidence at the 0.05 1% level of significance, 0.01 level of significance to support the claim that company 1 has a higher rating than company 2. And again, guys, the level of significance is the maximum allowable probability of making a type 1 error, of rejecting the null hypothesis when actually it is true. So there is still a chance of making a mistake when you perform a test, but we're reducing this mistake to 1% only. That's number 7. Number 8, almost done with the review. Adults aged 18 years old and older were randomly selected for a survey on obesity. Adults are considered obese if their body mass index is at least 30. The researcher wanted to determine if the proportion of men who are obese in the South is more than the proportion of Southern women who are obese. Test at the 1% level of significance. Would you guys agree with me that it's not a mean now, it's a proportion? And he wants to check if the proportion of men is larger, who are obese, is higher than the proportion of women. So that should be very easy to state. P1 less than or equal P2, and then HA will be P1 greater than P2. So P1 is for men and P2 is for women, and that's the claim. Okay, you have the X value and you have the N, the X value and the N. So this is X1 and this is N1, guys. This is X2 and this is N2. And so it's going to be a 2-prop z-test. Once he talks about proportion, it's a proportion test. There is only one test, which is the 2-prop z-test. Okay, let's see. Stat tests. There's the proportion z-test, guys. And let's do the math. X1 is the smaller number, so 42,768. Now the larger sample size, which is 155,525. X2 is 67,179. And N2 is 248,775. And we're testing if the first proportion is larger than the second proportion. See, determine if the proportion of men who are obese is more. So that's what it says. And you hit calculate. And I got Z to be 3.44. And the p-value, look at the p-value, guys. There's an E minus 4. Don't ignore that. So Z is 3.44. And the p-value, which is, I'll write it down first, guys, so you know what, 2.8795 E minus 4, which means you have to move the decimal place 4 digits to the left, so it will be 0.0002879, which is definitely less than alpha. Once you see an E, it's a very small p-value, so you reject HO. And conclusion, there is enough evidence at the 1% level of significance to support the claim. We are reviewing section 8.4, guys, difference between two proportions now. All right, so that's number 8. Any questions about 8, guys? 9. A group of friends debated whether more men use smartphone than women. They consulted a research study of smartphone use among adults. The results of the survey indicate that of the 973 men randomly sampled, 379 use smartphones. For women, 404 out of the 1,304 who were surveyed use smartphone. Test at the 1% significance level. It's pretty much the same as number 8, guys. So for number 9, we have men and we have women. We have N1 for the men is 973 and X1 to be 379 who said they use smartphones. N2 for the women, we have 1,304 and X2 we had 404. And he's asking you guys to check if this is men, P1. He's asking you to check if P1 is greater than P2. Proportion of men is higher than the proportion of women. Higher means more than. So let me just show it right here. So we need to check the proportion of men who use smartphone is higher than the proportion of women. That would be the claim. And you guys can tell that this would be the null hypothesis. And this is a 2 proportion Z test. And to do this, there you go. Same test. We're going to go back to the same test. So X1 is always the smaller number. So you begin with 379, then the sample size. Then X2, he says 404 women out of what? 1304 use smartphones. And check that P1 is greater than P2. It's exactly same screen as the previous one. So Z is 3.96. And look at the p-value. There's E minus 5, guys. So it's almost 0. Z 3.96. Once Z is large, the p-value is going to be very small because that's very, very unusual. So it will be 0.000037, which is less than alpha. We reject HO and we support the claim. There is enough evidence at the what? 5% level of significance to support the claim. And now the last one, which number 10. And let's see what's number 10 is about. North Carolina University looked at factors that affected the success of students in a required chemical engineering course. Students must receive a C or better in the course to continue as chemical engineering majors. So we consider a grade of C or better as a success. Is there a difference in the proportion of male and female students who succeeded in the course? Okay, can someone tell me what would be the null and the alternative from just the first statement? What do you guys think?
Equal to or not equal to?
Yeah. Difference, not equal to. That's what it means. And that's the claim. That's the claim C. And you have the data, guys, men and women. So let's do the women data first. So X1 and 1. X1, guys, I got 46 out of 89. Now let's do the men next. X2 and 2. 6190. That's it. That's all I need to run the test. Let's run the test, guys. Clear, stat, 2 sample, 2 prop Z test, 46, 89. X2, guys, is 61. 90, probably there is a difference. Let's see. not equal to, and hit calculate. Negative 2.1, negative 2.20, that's Z. So 2 prop Z test again. Z is negative 2.20, p-value is 0.0281. And what's alpha? 5%. So that's less than alpha, guys. Reject HO. There is. When you reject HO, you start with there is. When you fail to reject HO, you start with there is not enough evidence. There is enough evidence at the 5% level of significance to support the claim. So we can support the claim. To support the claim. Oops, sorry.